Here's the next question, number 53. Two identical unloaded generators are connected in parallel as shown in the figure. Both the generators are having positive, negative and zero sequence impedances of J.4 pu, J.3 pu and J.15 pu respectively. If the pre-fault voltage is 1 pu for a line to ground fault at the terminals of the generators, the fault current in pu is dash. Okay, so what we can do first is to try and put it all down in the form of a diagram so that we have a good view of what's been given to us. So we have two generators here, and the sequences are also given. The sequence impedance is positive, negative and zero. So let me just draw it here for you. So we have the positive, the two generators here, and then we have the negative sequence impedance, and then we have the zero sequence impedance. Okay, so this is J.15, this is J.15, J.3, J.3, and here we have 1 pu given to us, 1 pu as as the generator side, and that's 0.4. This is also J.4. Okay, so we have written down the positive, negative and zero sequences impedance, and let's call the current that passes through here as IA1. Okay, alright, so this is what we have. Now let's say that a line to ground fault occurs at the terminals of the generator. Okay, so now a fault occurs, and when that happens, the diagram would turn into, now here we are writing a equivalent circuit diagram. Okay, we're going to draw out an equivalent circuit diagram here. Let's calculate the values. Okay, so here this is the current IA1, this is 1 pu. Alright, so when a fault occurs at the terminals, this portion here becomes open circuit. Therefore, we have just this impedance, which is the same here for our equivalent circuit after the fault has occurred. The zero sequence impedance will remain as 0.15. Now let's calculate for both these impedances. Now here these two are in the form, are in parallel connection. So 0.4 and 0.4 in parallel will give us 0.2J. You know how to calculate the parallel combination of any resistance as such, right? So that's R equivalent is equal to R1 R2 divided by R1 plus R2. So we can use this in order to calculate the impedances that are connected in parallel here. So 0.4 will give us 0.2, and 0.3 and 0.3 in parallel will give us a value of J.15. So we have 0.2 as the equivalent positive impedance, J.15 as the equivalent negative impedance, and J.15 as the zero sequence impedance. That's because the fault has occurred and it shall remain the same. Okay, so the next step is to find out what the current is, because that's what's been asked. If the pre-fault voltage is 1 pu for a line to ground fault, the fault current, so we are finding out the fault current. So let's calculate the fault current here, IF. Okay, so because we have three sequences given to us, we have the positive, negative and zero sequences, fault current can be found by multiplying 3 times of the current that goes through the entire circuit IA1, 3 times IA1. This is a good formula, a very useful formula to remember. For a line to ground fault, IF is equal to 3 IA1. So this gives us 3 into 1 divided by the sum of all the impedances that we calculated, 0.2 plus 0.15 plus 0.15, which gives us 3 divided by 0.5, that's 6 per unit. So the fault IF is 6 per unit. This is the final answer. Now let's see if it matches. Oh no, it's not a multiple choice. So the final answer is 6. Well, I hope this has helped.